Now we have seen the formulation for four-noded quadrilateral element based on isoparametric formulation by using natural coordinate system. Now next, let's see the quadratic element. We know that for fully quadratic element we have to consider the 9 nodes. If we consider the rectangular element, say 9-noded rectangular element. So node 1, 2, 3, 4, they are called primary nodes, and node 5, 6, 7, 8 and 9, they are called secondary nodes. So 9-noded quadrilateral element is a fully quadratic element. It is a fully quadratic element. However, node number 9 is not useful to establish the inter-element compatibility, because node number 9 is within the element. The node doesn't have any connections with adjacent element, because in finite element method we assume that the elements are connected to adjacent elements at nodes only, at common nodes. So therefore we avoid this node number 9. So if we avoid the node number 9, then it becomes partially quadratic element, and such a partially quadratic 8-noded element is called serendipity element. And if we keep the node inside the element, within the element, then the element is said to be Lagrangian element. And 8-noded is a partially quadratic element, is called serendipity element. Now our next question is to develop the shape functions for 8-noded partially quadratic element or serendipity element. Again, here also, if you want to assume the displacement function at any point within the element, now as usual, because we are going to use the natural coordinate system, so the coordinates here will be -1, -1, and the axis, natural axis system will be like this. This is eta, this is xi, and this is 1, -1, this is 1, 1, this is -1, 1. So therefore the coordinate of node 5 will be, so this is 0, -1, this is 1, 0. The coordinate of this 7 is 0, 1, and coordinates of 8 is -1, 0. Now these are the coordinate system. So let's derive first the shape functions for 8-noded partially quadratic element. See, what will be the displacement function? Displacement function will be u equal to n1 u1, n2 u2, plus n3 u3, plus n4 u4, plus n5 u5, plus n6 u6, plus n7 u7, plus n8 u8. Similarly, you can write for v in this direction, that is n1 v1, plus n2 v2, plus n3 v3, plus n4 v4, plus n5 v5, plus n6 v6, plus n7 v7, plus n8 v8. What is important is to find out shape functions. Once we calculate the shape function, then the element stiffness matrix can be calculated easily by using the integration in the form of natural coordinate system. Now how to calculate? There are two methods we can use, three methods we can use to find out the safe functions. First one is by using Lagrangian formulas. Second one is by using method of superimposition, and third one is by setting of equations of line. So what we will do, we will use the Lagrangian interpolation formula for secondary nodes, and then for primary nodes we will use both the methods, that is by method of superimposition and by using the equations of lines. Now first, say the safe function for fifth node n phi u is equal to, now Lagrangian interpolation formula, this is xi minus xi1 xi minus xi2 divided by, this is xi phi u minus xi1 xi phi u minus xi1, and in eta direction we have eta minus eta 7 divided by eta phi u minus eta 7. So this is equal to, let's substitute the coordinates, this is xi minus xi1 minus minus plus 1, then again xi minus xi2 is 1 divided by, this is minus 1, xi phi u is 0, xi phi u is 0, minus minus plus 1, then xi phi u again 0, this is minus 1, into eta minus eta 1 is 1 divided by, this is 0 minus 1. So this is now equal to 1, we can write down 1 plus xi, 1 minus xi, 1 minus eta divided by 2. So this minus 1 plus, again this minus plus. So this is n phi u. So let's derive for n7, sorry, n phi u n6 is equal to, n6 is equal to, now in xi direction this is xi minus xi8 divided by xi6 minus xi8 into eta minus eta 2 eta minus eta 3 divided by, so this is eta 6 minus eta 2 eta 6 minus eta 3. Now substituting coordinates, this is xi minus xi8 is minus minus plus 1, xi6 is 1 plus 1, eta minus xi2 minus minus plus 1, sorry, eta 2 is plus 1, now eta minus eta 3 is minus 1 divided by, now eta 6 is 0 plus 1 0 minus 1. So this becomes 1 plus xi 1 plus eta 1 minus eta divided by 2. So this denominator, this is 1 plus 1 2 minus 2, and this minus, it becomes plus. Now similarly n7 is equal to, now n7 is here, so this is 1 plus xi, 1 minus xi, and 1 minus eta divided by 2. And n8 we can derive this in similar manner. Then n8 will be equal to, so this is 1 plus xi, 1 minus eta, 1 plus eta divided by 2. Now we have calculated, say, functions for secondary nodes, that is 6, 7, 5, 6, 7 and 8. Now by using method of superimposition, n1 for 8 noded, equal to n1 for 4 noded minus 1/2 n5 minus 1/2 n8. So we can n1 for 8 noded equal to n1 for 4 noded minus 1/2 n5 minus 1/2 n8. Now substituting this, so for 4 noded we know that this is 1 plus 1 minus xi, 1 minus eta divided by 4 minus, now 1/2, now n5 we know, the n5 is 1 plus xi, 1 minus xi, 1 minus eta divided by 2 minus 1/2, n8 is 1 plus xi, 1 minus eta, 1 plus eta divided by 2. So after simplifying this, so what we get is n1 for 8 noded element, and this comes out to be n1 for 8 noded minus 1 by 4, 1 minus xi, 1 minus eta, 1 plus xi, 1 plus eta. So this will be n1 for 8 noded element. Now similarly we can find out n2, n3 and n4. So n2 for 8 noded equal to n2 for 4 noded minus 1/2 n5 minus 1/2 n6. So after substituting for n5 and n6 and simplifying, what we get is minus 1/4 n2, this is 1 plus xi, 1 minus eta, 1 minus xi plus eta. Similarly n3 for 8 noded equal to minus 1/4, 1 plus xi, 1 plus eta, 1 minus xi, 1 minus eta, and n4 is equal to minus 1/4, 1 minus xi, 1 plus eta, and into bracket 1 plus xi minus eta. So now we have calculated the safe functions for all nodes n1, n2, n3, n4, n5, 2 and 8. Now this is by using the method of superimposition. The safe functions now we can evaluate by using the equations of line, by setting up equations of line passing through these nodes. Now how to use these equations of lines? Now let's draw the lines passing through these points. Lines passing through the nodes. Suppose if we pass the line through this nodes, we know this is the equation of line. This is xi equal to 1, means 1 minus xi equal to 0. So this is 1 minus xi equal to 0. So xi is 1, xi equal to 1, so 1 minus xi equal to 0. Similarly, if you draw this line, the equation of this line will be, this is actually eta equal to minus 1. Eta is minus 1. Means 1 plus eta is equal to 0. So similarly, you draw the line, this line, parallel line to eta axis. So this is xi equal to minus 1. So equation of this line will be 1 plus xi equal to 0. 1 plus xi equal to 0. Now again, this line, so equation of this line, so let's write down here. So this is eta equal to 1, means this is 1 minus eta equal to 0. This is 1 minus eta equal to 0. Now this, for horizontal and vertical lines, we have written the equations. Let's write the equation for line passing through 7 and 8. So here the 7 means xi is 1, xi is minus 1, eta is 1. So the equation of this line will be 1 plus xi minus eta equal to 0. Similarly, line passing through 5 and 6, nodes 5 and 6. What is the equation of this line? The equation of this line will be, this is actually xi is 1, eta is minus 1, means 1 minus xi plus eta equal to 0. So let's, the equation of line, so write the equation of line passing through these points. So this equation of line, so this is passing through 5 and 8, xi is minus 1, eta is also minus 1, so this is 1 plus xi plus eta equal to 0. Now write the equation of line passing through these two. So the equation of line for this is, so this is xi is 1 and eta is 1, so that is 1 minus xi minus eta equal to 0. Now we have expressed the equation of lines passing through the nodes. Now by using these equations, we can develop the shape functions. Now n1 will be equal to, say, some constant k1 into, let's see the equations of lines. n1 is here, n1 is here. So this is 1 minus xi minus, sorry, this 1 minus xi, 1 minus eta. Its coordinate, both are negative, negative. So here it is 1 plus xi plus eta. So this equation of this line and equation of lines passing through node 1. So now we have to find out the constant k1. So at node 1, what is xi? Xi is minus 1. What is eta? Eta is minus 1. And therefore n1 must be equal to 1. That is property of shape function. This is 1. Now if we substitute this, 1 equal to k1 into bracket 1 minus minus plus 1, 1 again minus minus plus 1, and this is 1 minus 1 minus 1. So this gives us k1 equal to minus 1 by 4. K1 is equal to, because this is 2 2 into 2 4, and here what is left is minus 1, so minus 1 by 4. Therefore n1